Welcome to Balaji Education YouTube channel. In this video we are going to see the fourth part of number system topic. In this we are going to see the divisibility and the remainder topic. At very first let us see the concept. In the concept our first topic is like factorial. Factorial means the symbol of factorial is this one. So factorial means, suppose let us see by the example. If we have 4 factorial means it is meaning like 4 into 4 minus 1 which is 3, 4 into 3 again 3 minus 1 which is 2, like 4 into 3 into 2 again 2 minus 1 which is 1, like 4 into 3 into 2 into 1 we need to multiply in such a manner. By making the difference of the 1 we need to multiply to the left side of the number. So if we do so, then it is a meaning like it is a factorial. Suppose if we have n factorial, so this is the formula, means n factorial means n into n minus 1 into n minus 2 into so on up to we need to make last as 1. So 4 factorial means 4 into 3 into 2 into 1. So if you multiply all these terms, then you will get the value as 24. Again 3 factorial means 3 into 2 into 1 which is 6. Now let us solve a few questions regarding this topic at here only. Like our question is like we need to find the value, what is the value of 6 factorial by 3 factorial. Like the 6 factorial is 6 into 5 into 4 into 3 into 1 by the 3 factorial means 3 into 2 into 1. If you cancel out like this, then you are left over with 6 into 5 30, 30 into 4 which is 120. So this is the one type of way you can solve like this, or you can do like this, like 6 into 5 into 4 into, so 3 into 2 into 1 which is nothing but 3 factorial by 3 factorial. You can cancel out directly here only, then this will be give the same result. Now let us see the another type of question. Find remainder. This is nothing but remainder when 1 factorial plus 2 factorial plus 3 factorial plus so on up to 100 factorial is divided by 3. Then we need to calculate the remainder. So like in the question it is given like 1 factorial, 2 factorial plus 3 factorial plus so on up to 100 factorial by the 3. So 1 factorial by 3, then we are left over with the remainder is 1. 2 factorial by 3 means 2 factorial is nothing but 2 into 1. 2 by 3 we are left over with the remainder as 2 here, like 2 1 plus 2 plus 3 factorial means 3 into 2 into 1. So it is a multiple of 3 na. So here you will left over with the value 0. Again 4 factorial means 4 into 3 into 2 into 1, nothing but you can write like this, like 4 factorial like 4 into 3 into 1. So inside this you have a 3, value 3. Again it is a multiples of this 3, means if you divide with the 3 then you will get the remainder as 0. Similarly with the 5 factorial and similar with the 4 factorial and the 5 factorial up to 100 factorial, if you divide with the 3 you will get the same values as the 0. So it's nothing but in the numerator you need to add these values like 1 plus 2 plus so on 0 by 3 which is nothing but 1 plus 2 by 3 which is like 3 by 3. If 3 by 3 means the remainder will be the 0. Now this is in the option A. Now our next concept is Wilson's theorem. P minus 1 factorial by P, the remainder will be the P minus 1 only. So if we divide P minus 1 factorial by the P, then you will get the remainder as P minus 1 only when this P is a prime number. I think you all know the concept of the prime numbers, like it is a divisible of only by itself or by the 1. So if such a numbers are there, then it is known as a prime numbers. If p minus 1 factorial by the p, then the remainder will be the p minus 1 only when p is a prime number. Example, here 4 factorial by the 5. First you need to check is the denominator is a prime number or not. So here the 5 is the prime number. Then it is like 5 minus 1, like p minus 1, which is 4 factorial by the 5. Then the remainder will be the 4. Like I will make you clear here, like 4 into 3 into 2 into 1, which is known as the 4 factorial by the 5. If you multiply all this, you will get the value is 24 by the 5, which is like 5 4 the 20. The remainder will be the 4. So here you can, the theorem has been proved. So you need to remember this formula. Now let us solve few questions regarding this. Like 58 factorial by the 59, we need to check the denominator is the prime number or not. So 59 is a prime number, like p as 59, p minus 1, which is the 58. So the remainder will be the 58 only. Now 28 factorial by 29. So we need to check the denominator is a prime number or not. So 29 is a prime number. 28. So here we have 28, like 29 minus 1. The remainder will be 28 only. Now let us move to the next theorem or the next topic in this concept, like Fermat's theorem. So the theorem which states like a power p minus 1 by p, the remainder will be the 1 when the denominator like p is a prime number and a and p is the co-primes. Co-prime is the HCF of a and p will be the 1 only. So there is no other highest common factor in between the a and b. So whenever you will find this type of means, the remainder will be the 1, like a power p minus 1 by the p. When the p is a prime number, a and b are co-primes, then the remainder will be the 1. Now let us see the few questions regarding this theorem. Like 2 power 82 by 83, we need to check the denominator is a prime number or not. So the denominator is a prime number and 2 and 83 are the co-primes, then the remainder will be the 1. Again the here 8 power 52 by the 53, here you need to check this is the denominator is the prime number or not. So the denominator is the prime number. So again a and like the numerator 8 and the 53 are the co-primes. Again 53 minus 1 is in the power of the numerator. Now the remainder will be the 1. These are the three concepts will make easy to solve the questions. Now let us see the few questions regarding this concept. Now our first question is, find the subtraction of the remainders of the two terms like 46 factorial plus 5 by 47 and 2 power 100 by 101. So let us calculate remainder for this and the remainder for this. Then later we are going to subtract these two terms, the remainder of these two terms. So at very first let us find the remainder for this, like 64 factorial plus 5 by 47. So when you see this, like 64 factorial by 47, which is too much similar to the second concept or the second topic in the concept, like 46 factorial by 47, the 47 is the prime number and which is like the denominator minus 1 factorial. So here the remainder will be the 46 only, like here the directly the remainder will be the 46. Again 5 by 47, the remainder will be the 5 only. Now if we sum this together, which is like 51 by 47. Again if we calculate the remainder to this, then 47 1 the 47 and the left over the value is 4 as a remainder. Now let us calculate the remainder to this, like 2 power 100 by 101. So it is a very much similar to the third topic, like Fermat's theorem. So here 101 is the prime number and 2 and 101 are the co-primes and the numerator will be the denominator minus 1. The remainder will be the 1 only. So we need to subtract these two terms, like 4 and the 1, the subtraction will be the 3. So which is equals to the value 3, which is in option B. Now let us move to the another question. The question is 4 power 54, like 4 power 54 by 53. We need to calculate the remainder. So we need to modify these things to the relative theorems. Like we have it is a very much similar to the third theorem or the third topic, Fermat's theorem. You can see, like I am converting this 4 power 54 like this, like 4 power 52 into 4 power like 2. So if we multiply this, the powers will be the added. Like I have converted this 4 power 54 as 4 power 52 into 4 power 2. So when you again convert, then it will convert to this one by 53. Now it has been converted to the third topic. So here the remainder will be the 1. So because 53 is a prime number and 4 and 53 are the co-primes, here the value is the denominator minus 1. So here the remainder will be the 1. 1 into, it is like 4 power 2, which is like 16 by 53, which is the remainder will be the 16 only. Now 1 into 16 by 53 will give the same remainder as 16. So the remainder will be the 16 here. Again let us see this type of question, like 5 power 103 by 101. So modify these things to the relative theorem. Like I am converting this like 5 power 100 into 5 power 3, which is equals to 5 power 103 by 101. Now 101 is a prime number and 5 and 101 are the co-primes, and here the numerator is the denominator minus 1. So here the value is 1. Again 5 power 3 is like 5 square is 25 into 5, which is like 125. Now 1 into 25, which is like 125 by 100. Now the remainder will be 100, sorry, here 101. Now the remainder will be the 101 into 1 ja, which is 101. Now leftover value as the remainder like 24. Now let us see this question, like 52 factorial by 53. It is too much similar to the Wilson's theorem. Like here you will get the value as p minus 1, like 52 only. Here p is as a prime number and here it is like denominator minus 1. So here we got the value as 52 only because from the Wilson's theorem. Now 2 power 52 by the 53, which is like, here we will get the like 53 as the prime number, 2 and the 53 are the co-primes, and the denominator minus 1 in the numerator. So the denominator minus 1 in the power of the numerator. So here the value is directly as 1. So here you will get the value like 52 plus 1 by the denominator value, which is like 53 by 53. The remainder will be the 0. So this is how we can find the answers to the questions in a short period of time with these theorems. So if you really like my video, do a like and support by the subscribing. If your friends are preparing for the aptitude, please share my videos. Thank you for the watching.